Going to continue on with the gateway questions. This is Math 104, number 44, and we're in a new category. Number 44 through 53 are all going to be about solving equations using substitution. Most of the time, when we substitute, we're going to be left with a quadratic equation. Let's see how this works. Here, we're going to solve for a, and we have this equation in front of us. A to the fourth minus 7a squared equals negative 10. Now, when we're looking for something to substitute, we're looking for relationships between the variables and their power. So I'm going to rewrite this just a little bit. When I see a to the fourth, keep in mind that 4, this is kind of a silly thing to say, can be written as 2 times 2. So when I see a to the fourth, I can write this as a 2 times 2. Now, when you product exponents, you can put them outside of parentheses. So a to the fourth is equivalent to a squared squared. So let's rewrite this problem. Instead of a to the fourth, we have a squared squared minus 7a squared equals negative 10. Now when you look at the problem after I've rewritten it, in particular after I've rewritten a to the fourth, what you see is a squared appearing twice. This is an opportunity to substitute. We can kind of collapse a squared into a simple variable, giving us a new, easier equation. So let's do that. Let's keep in mind that a squared is now x. And let's rewrite this entire problem, and it will be a nice quadratic. So instead of a squared, we have x. Instead of a squared, we have x. There's our quadratic equation. Let's rewrite it the way we like to see quadratic equations. X squared minus 7x will add over the 10 plus 10 equals 0. So we've substituted. Now we have x's instead of a's, but we're still looking for a's. We have a new equation which we need to solve. This quadratic, we could use the quadratic equation, but I think it's a little easier to factor this. And I would factor this using the AC method. Remember, 1 is a, negative b is c, or negative 7 is b, and positive 10 is c. Now when we're trying to factor this, we're looking for two numbers which add up to a or add up to b and multiply and equal a times c. Those two numbers, what do we see here? Trying to break up 10 through products, 2 and 5. Negative 2 minus 5, that's negative 7. That's how we'll factor this. X minus 7 and x minus 2. Oops, sorry, 5 and 2. X minus 5 and x minus 2. So negative 5, negative 2 gives us positive 10. When we multiply them, negative 5 minus 2 gives us negative 7. So we factored this. Now we can find the solutions. And they're here in these little pieces. When we have two things producting equal to 0, that gives us two solutions. X minus 5 equals 0, or x minus 2 equals 0. Two solutions that pop out. Here, x is 5, or x is 2. So, substituted, rewrote every a as x, solve this new equation. We have solutions for x. Now we need to unsubstitute. So we'll go over to our substitution. If you look at the substitution, x is equal to a squared. Well, what's x equal to? Sometimes it's 5, sometimes it's 2. So 5 equals a squared, or 2 equals a squared. Our goal is to solve for a. So we'll take the square root of both sides. Keep in mind, plus or minus. And we find 4 solutions. 2 solutions for the x because it was quadratic, degree 2. But keep in mind, a started as a 4th degree polynomial, so we're possibly looking at 4 solutions, depending on if we're going to want complex numbers or not. So 4 solutions, plus or minus the square root of 5, plus or minus the square root of 2. And when you check your solutions by plugging them in, you're going to find that all of the solutions are acceptable.